Okay, live at the palace. All right, so we're going to review the properties that we just did. That's a little loud. And then we'll talk about two new properties today. One is an inverse and one is a composition. But let's just review the properties of functions that we have. So just go ahead and put these down, even though it's a little bit of review. And then we'll lead into right into the new properties. Properties of functions. So the four properties that we have that I've taught you is remember the good old, some of you are still, and I'm going to go over the quiz with you tomorrow. I didn't have time to grade it yet, but I will get time tonight. F plus g of x is going to be f of x plus g of x. Okay, that was the sum property. It said if you want to add functions, we are allowed to add two functions together, no problem. We can just collect like terms, all that good stuff. And if we can add, we can also subtract. So we have f minus g of x, which was just f of x minus g of x. That's what that means. That's really what some of you still, I think, are having a hard time with, even on the quiz as I was watching. Some of you are still kind of questioning yourself, what does it mean? You need to be able to take and look at the expression and interpret what it's telling you to do before you do the algebra. Okay? The third property was f times g of x, which is f of x times g of x. The next property was f divided by g of x, which is f of x divided by g of x. And that, if you remember, we're going to talk more about this in the weeks to come. G of x cannot equal 0. The denominator cannot equal 0, and we'll discuss that a little bit more as we get into talking about different types of functions here after we're finished with function properties. The two new properties that I want to go over with you today, the first one, this will be property 5, is called a composition. Okay, it's called a composition of function. Composition of functions. And when you read this the first time, you're going to think it says a word, but it doesn't. It's f circle g of x. Remember, g and f are both functions. You have function f and you have function g. So we're going to compose two functions. We're going to compose two functions. So f of g of x. Now all this means, you need to be able to interpret. A lot of people read this as fog x. Looks like fog, right? Okay. Maybe some of you just think this is all just foggy. I don't know. But it is f circle g of x. Now that circle does not mean multiplication anymore. When we have an open circle like that, that's going to mean composition. And what we do, and this is very, very, very useful, and I'll explain why it's useful here in a second. It means you're going to take f, and you're actually going to take function g and plug it into function f. And this is the idea of an assembly line. If you think about how an assembly line works, you start out the beginning of your assembly line, maybe a barrel of fun. We can relate to that because we all eat barrel of fun chips, right? Nobody eats Doritos in here. Okay? Everybody eats just barrel of fun chips. So anyways, if you do, and you know the potatoes come in on the conveyor belt, and then they go into a machine, and I don't know what happens to them. I don't know what happens to barrel of fun. Does anybody know what happens next?
They slice them, they wash them, they slice them. And they
wash them and slice them. And then you take that result, and then it gets put into another machine. Then something happens to it there, and then that result gets put into another machine, and then all of a sudden, after it goes through, different machines, you get your product, the potato chip. I went to the Louisville Slugger Museum. Is anybody a baseball player? Okay, baseball player. I went to the Louisville Slugger Museum, which Louisville Slugger Museum, they make the Louisville Slugger bats. It's in Louisville, Kentucky, or you say Louisville or Louisville or Louisville or whatever. Louisville. I went there and they show you how they make their baseball bats. Okay, and I did not know this. Baseball bats for major league players can sell, one baseball bat can sell for up to $10,000 to $15,000 a bat. For one bat. I thought that was the most outrageous thing ever. And they made the bats specifically, like they showed us some of the bats they made for like Derek Jeter at the time. He gets some of his bats there, and they showed us like a box that was going to go to Derek Jeter and of these baseball bats. And actually, they they had they had a Babe Ruth bat there that he had some of his home runs with. One Hank Aaron, and you could actually hold it. It was an actual bat that Babe Ruth hit a home run with, but you had to wear like plastic gloves, and you could hold the bat. You know, it's just crazy, all this cool stuff. But when I went there and we went through, what they do is they just start with this big block of wood, and it goes through and they spin it and they cut it into a cylinder. And then it goes to the next machine, and then they do something to get the end of the bat. And then all of a sudden, it kind of looks like this caveman club. And then it goes into the next machine. And you got to watch, we got to go through the whole thing and see a Louisville Slugger bat made all the way to the end to where they glaze it, and then they put the Louisville stamp on it. It was really cool seeing how they did all this stuff. And this is the idea of a composite function, is that you take the result of one function and you plug it into something else. So let me explain this in the idea of an assembly line. If I have f of g of x, I want you to start and understand that the way you're going to do a composite function is you start with the most inside part of the function. Find the most inner part of the function. So I want you to think of it as like, okay, this is the function f of g of x. Find the most inside part, okay? It would kind of be like if you're thinking, you know, I don't want to take this to the extreme, but when you go winter clothing here, you put on your pants and you put on your shirt first. We'll start there, and then you put on, you know, like your sweater and sweatshirt, and then, you know, or actually you probably put on your long underwear first, you know, or tights or whatever. Then you put your pants on, then you put a t-shirt on, then you put a sweatshirt on, then you put your coat on, then you put your snow pants on, then you put your gloves on. And you think, you finally get to these outer layers. What I want you to think of is get to the inside layer, or think of an onion. An onion has multiple layers. We need to get to the most inside layer of the onion. The most inside layer of the onion, the most inside part of this function is x. So we start with x, kind of on the assembly line. That would be like the potatoes at Barrel of Fun, or this block of wood at Louisville Slugger Museum. And what happens is x gets plugged into g. So we're going to map, it's going to get, x is going to get plugged into function g, okay, whatever function g is, and out is going to come g of x. That'll be your output. X is your input. Remember, what's in the parentheses is the input. G of x is the output, which is really just a what? What is g of x really? Somebody say it. Come on. It's just a y value. Thank you. You guys said it. Then I'm going to take g of x, so I'm here now, and I'm going to plug that into function f. So now g of x becomes the input, and what you get is f of g of x, which is also a y value. So you just keep building. And here's the thing, I've only composed two functions here. Could you compose more than one function? Or could you compose more than two functions? You can compose 3, you can compose 4. So I could do f of g and come up with another function, h. I could come up with f of g of h of x. I could do f of g of h of j of x. And you can come up with as many functions as you want and compose things as many times as you want. And this is the idea of a composition of a function. Is that I start on the inside, I plug into the next function, then I take that result and plug to the next outside function, take that result, plug in the next outside function, take that result, plug in the next outside function. So if I make it a little more complicated, so that's fog x, that's what fog x looks like. You can also do g of f of x, which some people call goff or goof, goofx. Okay, so goofx would be g of f of x. So what that means is I take and I'd find f of x first, and then I'd take that result and plug it into what? G. Okay? Let's make it a little more complicated. Okay? We can have fog, we can have goff. Let's introduce a function f. And I always like to bring in some Star Wars, so let's go to the planet of Hoth. Isn't it Hoth? Hoth, but you know, Hoth. Close enough. All right, planet Hoth. Anybody excited about the new Star Wars film coming out? I'm so jacked.
I am kind of worried.
So here is h of what?
F.
F of
X.
x. So we've got a third function, h. So we can compose h with f. Could I compose f with h? All right, now let's make it really complicated. So now I've got an f, I've got a g, I've got an h. So here we go. I want you to write down what the interpretation will be. Let's go f of h of g of x. What does that mean? Fahog. Or fohog. What would that mean? F of h of g of x. What do it mean? Now, did I do enough parentheses? One open parentheses, one closed. One open, one closed. Ooh, I need one more closed. So f of h of g of x. Okay? Fahog. Alright? That would be composing three functions. And the way this would work, you would take x, plug it into g of x. Figure out what g of x is. What would you do next? Take that answer and plug it into h. Take that answer and plug it into, let's do one more. Let's go h of f of g of h of x. Tafago. It's Elvish for Gandalf is cool. Alright? So what would it be? H of f of g of h of x with how many closed parentheses? Okay, shut the front door, okay? 1, 2, 3, 4. Make sure you shut the door. So you take x and plug it into what? Take that result and plug it into? Take that result and plug it into? Take that result and plug it into? And now, I can introduce also something to you, one more composition, a special type of composition, which is called an iteration. Say it with me.
Iteration.
It just sounds cool. Okay, iteration. An iteration is when you want to repeat the same process over and over and over and over and over and over forever. You've never seen the same line apparently. Okay, forever. Okay, to the end of time. So an example of an iteration is if you wanted to take the same function. Does anybody know an example of where you want to take something, just keep repeating the same thing over and over and over and over and over and over and over again? Okay, I can't think of anything either. All right, but an example would be if you want to go f of f of f of x, and this would be called 3 iterations. Because how many times are you plugging it into f? You're going to start with some, just basic raw material, a start value, if you will. X is the start value. Then you plug it into f once, and then you're going to do what?
Plug it into F
Take
again.
that result, plug it into f again. Take that result, plug it into what?
F again.
F again. And you just keep repeating the same process over and over and over again. I'll give you an example of where an iteration takes place. Inside of your bodies, right now, 75 million cells just died and were replaced by 75 million new cells. And that happened in 1 second. And it just happened again. And it just happened again.
And again.
And again. No wonder you're tired all the time. Every second, 75 million cells dies off in your body and is replaced by a new 75 million cells. What is the body doing over and over again? What is it called? It starts with an M.
Mitosis.
Mitosis. Over and over again. It just keeps repeating the same process. The cell does what?
Split.
Divides, and it goes through, what are the stupid phases? Prophase, anaphase, telophase, and blah phase? I don't know. So whatever those phases are in mitosis. Do you remember the phases of mitosis? And what is it? It's just repeating the same thing what? Over and over and over again. That would be an example of an iteration. Okay? So this would be, ready? F of f of f of x. That's an example of an iteration. Okay? That's how we do a composition. Let's do an example, and then I'm going to show you one more thing today, and then we'll give you your homework. Okay? Sound good? How's this? So far, so good? Yeah, question?
When we have 3 f's, can we, is it the other part, or another way we can write it?
Oh, you mean like, is there a shorthand way? No. I wish there was. Sometimes what they'll do is they'll say just, you have a function f, perform 4 iterations. So then you take whatever the start value is, let's say I gave you x equals 4, you plug it into f, you get an answer. Then you take that answer, plug it into f again. Take that answer, plug it into f again. Take that answer, plug it into f again. That is all we're doing with a composition. We're just taking a result and plugging it into a new function. And then taking that result and plugging it into a new function. Taking that result, plugging it into a new function. That's the idea of compositions. All right, let's do a couple examples, and then I have a couple I want you to try. All right, so here we go. Let's go f of x. Write this down. 3x minus 4. Let's go g of x is equal to x squared minus 1. And let's go h of x is equal to the square root of x minus 2. Okay? All right. Let's start with just fog x. Start with that one together. We'll do a couple of these. A couple of examples here. Okay? Fog x. What does fog x mean? What does f of g of x mean? What does it mean? What's the interpretation? It means take f and plug one into f. G. So it's f of g of x. Always interpret what it means. Don't leave it as f circle g. Okay? Write down. Okay, that means take f of g of x. So here's what we're starting with. We're going to take x and plug into g. Well, that's just going to give me g of x. Well, it just so happens that we know what g of x is. What is g of x? This is a da-da-da moment, okay? Look at the board. What is g of x? Da-da-da. It's written down, okay? You can do da-da-da with me. Ready? 1, 2, 3. Da-da-da. Okay, it's better than duh, all right? We did that in high school. And when I was a senior, I took this class called medical technology, and we learned medical terminology. No, it was called medical terminology. And me and my friend, we took this class together, and we learned these really, really long, complicated words, like just crazy medical terminology. You know how they're just so long and you never can pronounce them, and like doctors start spouting them off. You're like, what did you just say? And they just said this. They just really said your tongue is swollen. But they said it, and it was like, you know, your Gulioptipos or something like that, just some crazy word. And so every time a teacher would introduce a new word, we'd be like, oh, yeah, you did? Yeah. Because it was some crazy word. You were just like, yeah, it totally makes sense. But anyways. All right. So g of x is x squared minus 1. So I'm going to take that, and I'm going to plug it into what? F of x. I'm going to take the whole function g. G of x is x squared minus 1. Does that make sense? So I'm taking g of x, and I'm saying, okay, I'm going to take that, whatever g of x is, x squared minus 1, and now I'm going to plug it into f. Okay? So what is f? F is this. So what I'm doing, f of x squared minus 1, I'm going to take the x out, and wherever there's an x, what am I replacing x with?
X squared minus 1.
That's exactly right. So I'm going to go 3 times x squared minus 1 minus 4. Now look at that. This is still, right here, that's still function f. Look at it. Stare at it a second. That's still 3x minus 4, but what I did is I took the x out and put what in?
X squared minus 1.
Do you see it? Okay, I'm just replacing it. Simplify it, you got your answer. And you just did your first composition. Okay, so let's distribute what? 3, so we're going to get 3x squared minus 3 minus 4. Final answer.
3x squared minus 7.
3x squared minus 7. There's your first composition. That's fog x. There you go. There's fog x. I want you to do goth x. G of f of x. Go ahead and try it right now. G of f of x. Erase this. Maybe I shouldn't erase it so you can see it, but you've got it written down. You should have had it written down. Okay, so I want you, what now?
G and F.
I want you to go G of f of x. Do this one. Write down what it means first and then figure it out. About what I just said. G, figure out what it means first. Those of you who are watching the video, since you're not, I did video record the first part of this, so you might watch it. Let's go with the souls in, so I can watch this on their own. Now, you're having to square something. I want to hope everybody gets the first step right, but simplifying might be a little touch and go. So this means G of f of x. Everybody agree? So what are we doing? What are we doing? Taking f of x and plugging it into what? G. Okay, so we're going to take f of x and plug it into g. So do we know what f of x is? Yeah, it's 3x minus 4. So I'm going to take g of 3x minus 4. So that's what I'm doing. I want to plug that into g. I want to take 3x minus 4, the whole 3x minus 4, and I want to plug all of this into g. All right, so let's do that. So here's the g function. All right, so it's going to be wherever there's an x, I'm taking x out. What am I putting in? What am I putting in for x? 3x minus 4. So it's going to be 3x minus 4 to the second power, and then what? Minus 1. There you go. That's plugging f into g. Now that's worth something to me right there. That to me, at least you get the idea of a composition. Now simplifying, if you want to get the right answer, you got to simplify correctly. Who remembers how we're going to do 3x minus 4 squared? It's the same way we had to do the one to the third power yesterday. Yeah. We got to go 3x minus 4 times 3x minus 4. Shazam. And then minus 1. Now we got to get our FOIL on, okay? 3x minus 4 times 3x minus 4. Ooh!
9x squared.
We're multiplying. So what's 3 times 3? 9. The only time we add is the exponents. So 9x squared. Remember, you are multiplying. When you multiply powers, you add the exponents, but the coefficients you still multiply. So 3 times 3 is 9. X times x is x squared. What about 3x times negative 4? Minus 12x. Some of you will figure out all you have to do is double this because it's going to be the same thing twice. Minus 12x. And then what?
16.
Plus 16. Minus 1. So we end up with 9x squared minus 24x plus 15. There's your answer for your goof. So don't goof it up. All right? We okay with that? Let's try one more together, and then we'll do a different problem, and then start on your homework here soon. I think I'm going to wait on inverse composition. Sometimes seems like it's enough. Let's do one more. Okay, let's go with, let's go with h of f of g of x. Now that would be, how would I write it the other way? We don't have to put it this way, but tell me how I'd write it the other way. It'd be h circle f circle g of x. So if I wrote it the other way, it'd be like this. It'd be h circle f circle g of x. Really, if you just kind of get the idea that those circles just get replaced by parentheses where you're just plugging in. Okay? So, try it. Give it a shot. So what's the most inside part? What's the most inner part of the onion? The x is the most inside, but then you plug x into g and you just get what? G of x. So do we know what g of x is? So we're going to take g of x and plug it in where? Into f. Try that right now. And then you'll take that result and plug it into h. So give it a shot. Let's see how close you can get. Now, some of you are going to ask, how do I go about this? Do I do it, kind of separate the problem and do parts of it and then finally get the final answer? I think that's the best way. I think focus on f of g of x first and then take that answer and then plug it in h. Probably the best way to do it. Come on, everybody give it a try. Even if you don't think it's right, try it. Set it back with this cover sheet. X squared minus 1. So you figure that out. It should be 3. Minus 4. Just minus 4. No, minus 1. That's right. You have to match 4 outside parentheses. Then you have to simplify that and then take that answer and plug it into G. So this is what I see some of you doing, which is good. Okay, you're figuring this out. And some of you might come over here and say, I'm just going to figure that out. What is f of x squared minus 1? What is f of x squared minus 1? Didn't we already do that? Yeah. It was taking and plugging x squared minus 1 into function f. Function f is up there. It's 3 times x squared minus 1 minus 4. What did we do there? This was the first problem we did. So it ends up being 3x squared minus 3 minus 4. Final answer? 3x squared minus 7. So that's what that is. That's what f of x squared minus 1 is. So then I take that and do what? Plug it into h. So I'm going to have h of 3x squared minus 7. So I'm going to take 3x squared minus 7 and I'm going to plug it into h. Where's the h function? It's up here. It's the square root of x minus 2. So what am I going to do? I'm going to take the what out? X out. And I'm going to replace the x with what? So go ahead and draw your square root symbol. Don't make it hard. Okay, don't make it hard. This is too easy to make hard. All right, you guys can do this. Just you got to take it step by step. If you take it step by step, you got this. All right, so I'm going to take out the x and put in what?
3x squared.
There you go. Put in 3x squared minus 7 goes in for the x. Minus what? 2. Now, do I really need the parentheses? Well, the parentheses really only showed what I was plugging in, but there's nothing distributed, is there? No, so can I drop the parentheses? So what we're going to end up with is the square root of 3x squared minus 9. Can I do anything else? No, and here's why. Square roots, you can't do square roots because this minus sign right here, don't circle it, but just watch me. This minus sign glues these two things together. So you can't take the square root of individual terms. People always ask me why. Let me show you why. A lot of people want to say that's 5. Anybody see how they might get 5? Well, think. How do they get 5? People think this is 5, but it's not. Some people want to say this is 5. Answer is 5, but it is not 5.
It's the square root.
They think you can go square root of 4 is what?
2.
And square root of 9 is what?
3.
And then 2 plus 3 is? You can't do that because this plus sign joins them together.
Would it be the square root of 12?
It's actually square root of 13. It's
Okay,
4 plus
okay.
9 is 13. That's the actual answer. Because I have to go 4 plus 9 first. See, a lot of people here might want to be tempted to say, can I take the square root of 9? The answer is no. Because that minus sign sticks together, that 9 and that 3x squared, and they can't be broken apart. Okay, it's like a marriage. It can't be broken apart.
No.
All right? Well, not in all cases, but you know what I mean. All right, we're going to do one more example, and then I'm going to get you started on your homework, and you should get time to get quite a bit done before we leave today. All right, let's do one more example, and I'll do some with numbers, okay? Here we go. F of x, pick another one. 2x plus 5. I'll give you 5 problems to try. Okay, 5 to try. And then I'll just give you A, B, C, D, and E, and you try them right now, and then we'll go over them. Let's go g of x is equal to x squared minus 4. And I'll go h of x is equal to the absolute value of x minus 3 this time. Okay? So first off, let's go ahead and try fog. It's a good one to start with. I have one more I want you to try. Try those 5. Go ahead, right now. Where's my mouse?